Okay, so today we get to talk about solving equations. We've already done a little bit with solving expressions. The difference between an equation and an expression. Does anybody know?
An expression is what the equation is without solving it?
Exactly. An expression basically is what the equation is without solving it. So it's the problem. The equation adds the equal sign and the solution, or the answer. So equation has equal sign. That's how I would always keep the difference separated. Okay, that's how I knew the difference. Okay, well, what if I'm solving an adding or a multiplying type equation? If I am given an addition or a multiplication problem, you will use the inverse, we talked about this not long ago, operation in order to solve for the missing number. So if I have an addition problem, I'm going to subtract the larger number and the smaller number. We saw a lot of problems like this in Saxon 4th grade math. When you start seeing what they look like, you'll be like, oh yeah, I remember doing this. Okay, you do the opposite operation to solve it. For multiplication, I would divide the larger number by the smaller number. So if I'm adding, in order to solve it, I'm going to subtract. If I am multiplying in my problem, I will divide in order to solve it. Inverse means opposite. We talked about that when we talked about our properties of operations, number properties. Remember, commutative, associative, identity, inverse is opposite. Okay, what about when I'm subtracting and dividing? If you don't know the total number of something, we're going to see several examples today. If you don't know the total number of something, you can use the inverse operation to find the missing number. So if I have a division problem, then in order to solve for the missing number, I'm going to use the inverse, which is multiply. If I have a subtraction problem, the inverse is adding, addition. If you are given the total, then you're just going to subtract or divide the total from the other number to find the missing number. Guys, these problems were all over Saxon, all over, because I'm constantly checking Van's work, and it's like literally has multiple problems like this. If you guys are used to this, I don't think that you're going to panic when you see it, because you're going to be like, oh yeah, I remember doing this. Okay, so here's several examples. All right, number one says B plus 1,600 equals 5,000. B, that's my variable. That's what I'm solving for. I'm adding 1,600 to B, and it should equal 5,000. So going back to my notes, am I given the total?
No.
Am I given the total?
Yeah.
I am given the total. 5,000. 5,000 is my total. So what does it say? When I have the total, I will either subtract or divide. Because it's adding, I'm going to do what? Subtract. The inverse of addition is subtraction. So it's already set up for me. I'm going to take my total. I'm going to subtract the other number that I'm given, which is 1,600. And that's how I figure out what B equals. To save time, it is 3,400. Okay, this time I have, for number 2, 400 plus X equals 6,800. Am I given the total? Yes, I have the total. The total is right here. I know that my total is 6,800. My other number is 400. So what can I do to figure out what X is?
6,800
minus, because I was adding, the opposite is subtract. So I'm going to do 6,800 minus 400. So my answer is 6,400. A good practice that you should get in the habit of doing is checking to make sure it works. So take your answer for number 1, 3,400, and add it like where B is. So we're saying that 3,400 is what B is. So I'm going to add 3,400 to 1,600, and it should equal what it says it equals. And did I get 5,000 like it says it is?
Yeah.
Yes. So I know my answer is correct. For the next one, I would plug in 6,400 for X, and then I would add 400 to it, and it gives me 6,800, so I know it's correct. So checking your work is a huge step to help you avoid making mistakes when we're solving for equations. Okay, the next one, X minus 80 equals 440. So this time I'm subtracting. So the opposite of subtracting is adding. So I'm going to do 440 plus 80. That gives me my answer, which is 520. And if I want to check it, I'm going to do 520, where X is, minus 80, and I better end up with 440 if I did it right. And I do. So I know that it's good. Okay, the next one is 10,230 minus X equals 8,000. So I'm subtracting. I know I want to find X, but does it make sense? Look at my note here. Notice how I have a little note here. It says, when you have the total, and it's a subtraction problem. Okay, this is where it can get tricky. You've done problems like this before. Okay, when you have the total, you're going to subtract the other given number to find the missing number. Okay, so this is what I'm starting with. I have some, this is how Saxon talked about it. I have some, I take away something to end up with what I have left over. I have some, subtract something from it, and then I have what I have left over. They worded it really like long phrases. Okay, so here's what I'm starting with. I take away something smaller, here's what I'm left with. So what I want to do is take my bigger number, 10,230, and subtract what? 8,000 from it. And that leaves me with 2,230. So I should be able to plug in this number here for X and end up with exactly 8,000. Are there any questions on that? So far, so good? Okay. All right, number 5. Y'all, we have tons of practice. We're going to feel really good about this. Okay, we're bringing it all back. All right, 500R. What does it mean when you have... This means multiply. Okay, so the opposite is divide. So I'm going to take my total, divide by 500, which means that R equals 50. Okay, the next one is also multiplication. 90 times R equals 810. So I'm going to work backwards. I'm going to do 810 divided by 90, which equals...
3 times.
Ooh, what's 81 divided by 9?
2.
9. Good.
Oh.
So it's just 9.
81.
And then you put the 0 at the end. That gives you 810. So just 9. Okay, now we have some division problems to look at. N divided by 3 equals 6. I don't know my big total answer, so I can work backwards and say, well, if something divided by 3 equals 6, then I can do the inverse operation and do 3 times 6, and that means that N equals 18. To check it, I would plug in 18 where N is, divide by 3 equals 6. Does 18 divided by 3 equal 6? Yes.
This is making sense.
The next one, 24 divided by P equals 8. 24 divided by something
3.
equals 8. But did I multiply this time?
No.
No, because I'm given the total number, the beginning number, what I started with. So I'm going to take 24 and I'm going to divide it by 8 to figure out what that missing number is, which is 3. To check it, I would plug in 3 where P is. So 24 divided by 3, it says it equals 8. Is 24 divided by 3 8? Yes, so they equal the same thing. So we know it works. Again, your little note there, when you have the total, divide the total by the other given number to find the missing number. It's the same as subtraction. Subtraction and division can get tricky sometimes. Subtraction and division can get tricky sometimes because you don't always use the inverse operation to solve it. If you are given the total as part of your problem, then you're going to still use that same operation that it's already given to you. So like number 8, the total's given to us, 24 divided by something. I'm still going to divide to solve it. Back up here, if you look at number 4, I'm given the total right here. I'm taking away something from the total. So to solve it, I just subtract the other given number from the total to figure out what that missing number is. So it's not always the inverse when you subtract and when you divide. You've got to look to see, what do you have, what do you know? If I have the total, I'm going to go ahead and subtract or divide. Okay, look at the last page. True or false equations. This specifically is something you have to be able to do as a 5th grade student. So when we get to determining whether an equation is true or false, for an equation, let me zoom in, hold on. Okay, for an equation to be true, the values on each side of the equation must be equal. Or true, yeah. But we're describing what makes it true, so we can't say true because it's like using a definition, you know. Oh, the definition of true is when something is true. You have to think of another way to say it, so that's why I said equal. But true could work too. Okay, our example that we're going to walk through together says, tell whether a plus 9 equals 15 is true or false when a equals 6. Okay, the first thing you're going to do when you are determining whether or not that is true or false is you are going to write out the equation. So I'm going to write out the equation given. A plus 9 equals 15. I'm going to start with my equation given. Then I'm going to plug in 6 for A. Why am I plugging in 6 for A?
So you know that they're equal.
Because it tells me right here that A equals 6, right? So I'm plugging in 6 for A because it tells me to. It says wherever there is an A, I plug it in. This is just like solving expressions the other day, how I'm just substituting in the value for that variable. Okay, step 3 is solve. Now that I have it plugged in, I can actually solve it. So what is 6 plus 9? 15. Okay, if both sides of the equation are equal, then the equation is considered true. These are both equal. So it is true. Okay, let's look at 2 more examples. I have m over 12. What does that mean again when it's over like? Divide, very good. So m divided by 12 equals 8. If m equals 84, we're determining whether or not that is true or false. So I'm going to plug in 84 for m, and then I'm going to solve it. What is 84 divided by 12? 7. Does 7 equal 8? No. So I'm going to put a slash through my equation to show it is not equal. That is a mathematical symbol that you will see again and again and again showing that it is not equal. So I'm going to make myself a little note right here. Means not equal. Well, guess what? On Monday, we're going to work with inequalities when they're not equal. So we're going to get there. Right now, we're just going to use the not equal sign. So am I going to circle true or false? False. Good. You want to try the last one? And then we'll check it. Okay, try it, check with your group, and then we'll check it whole group. Okay, so 8y means what operation? Multiplication. So I'm going to do 8 times 7. I'm plugging in 7 for y. Now I'm going to solve my equation. So 8 times 7 is 56. Does it equal 56? So it is